Hello everyone, in this tutorial I'll tell you how to draw shear force and bending moment diagram for a simply supported beam subjected to 2-point load. So this is the example of simply supported beam which carries 2-point loads. The first one is a 10 kN which is at a distance of 1 meter from the left hand side, and second force is a 20 kN which is at a distance of 5 meter from the left hand side. The total span of the beam is 6 meter. Now first label the diagram. This is point A, this is point B, this is C, and this is D. This is reaction RA and this is reaction RB. So first calculate the reactions RA and RB. So to calculate the reaction RA and RB, we have to apply the equilibrium conditions. So equilibrium conditions are sum of all horizontal forces are 0, sum of all vertical forces are 0, and sum of all movements about any point are 0. And then we have to consider upward forces as a positive and downward forces as negative, clockwise movements as a positive and anti-clockwise movement as negative. So first equilibrium condition is sum of all the horizontal forces are 0. So there is no horizontal force in this diagram, so this will not apply. Now the second equilibrium condition is sum of all vertical forces are 0. So in this diagram RA is acting vertically upward, so it is positive. 10 kN is vertically acting downward. Next is 20 kN acting vertically downward, and RB is acting vertically upward. So sum of all these forces should be 0. From this RA plus RB becomes 30. This is equation number 1. Now next equilibrium condition is sum of all the moments about any point are 0. So by taking movement about point A, so we have to consider A as center and find out the movement due to all forces. So first force is 10 kN. 10 kN is at a distance of 1 meter, and this tend to rotate the beam in clockwise direction. So this moment should be positive. Next is 20 kN is at a distance of 5 meter, and this tend to rotate the beam also in clockwise direction, positive. And RB is at a distance of 6 meter from point A, and this tend to rotate the beam in anti-clockwise direction, so this is negative. So sum of all these moments should be 0. So from this RB comes out as 110 by 6, it is 18.3 kN. By putting the value of RB in equation number 1, then RA comes out as 11.7 kN. Now the value of RA is 11.7 kN and RB is 18.3 kN. After calculating RA and RB, now we can draw the shear force and bending moment diagram. In this tutorial I'll tell you to draw shear force and bending moment diagram with the help of left hand right hand method. So first one is shear force diagram. So to draw shear force diagram, we have to take each point 2 times by taking its left hand side and right hand side and do the summation of all leftward forces. So first point is point A. So shear force on just left of point A. So on the left of point A there is no force, so this is 0. Now shear force on just right of point A. So place your finger on the just right of point A and sum up all leftward forces. So leftward forces RA. So RA is acting vertically upward, so this is positive 11.7 kilonewton. Next point in this diagram is point C. So shear force on just left of point C. So place your finger on the just left of point C and sum up all leftward forces. Again there is a single force 11.7 which is acting vertically upward. The next one is a shear force on just right of point C. So place the finger just right and sum up all leftward forces. So there are two leftward forces, 11.7 acting vertically upward and 10 vertically downward. So net is 1.7 kilonewton. Now next point is point D. So shear force on just left of point D. Again there are two forces, place the finger here on the left. There are two forces, first one is 11.7 and second one is 10. So net is 1.7 kilonewton. So next is shear force on just right of point D. So place your finger on just right of point D and sum up all leftward forces. So there are three forces on the left of point D. First one is 11.7 acting vertically upward, 10 downward and 20 downward. So net become minus 18.3 kilonewton. Again shear force on just left of point B. Now last point is point B. So again three forces are there, 11.7 minus 10 minus 20 equal to minus 18.3 kilonewton. Now shear force on just right of point B. Now place finger on the just right of point B and sum up all leftward forces. So there are four forces. First one is 11.7, second is 10 downward, 20 downward and 18.3 upward. So net becomes 0. Now each point got two values. Now we have to extend all these points on a reference line. So this is reference line, upward is positive, downward is negative. Extend all these points A, C, D and B on this reference line. Now plot all these values on this reference line. So first one is A has got a 0, second value is 11.7. So 11.7 positive, this is 11.7. Next point C is having first value 11.7 and second value is 1.7. Now next one is point D. Point D First value is 1.7. This is 1.7. Next value on day is minus 18.3. Minus 18.3. Then minus 18.3 and 0. Now I join all these points with a straight line. So this is our shear force diagram. Now to draw bending moment diagram, we have to take each point one time and calculate the moment due to leftward forces. So first one is point A. So bending moment about point A. So on the left side of point A there is no force, so no bending moment. Now second point is in this diagram is point C. On the left side of point C there is a one force, that is RA 11.7, and it is at a distance of 1 meter, and this tend to rotate the beam in clockwise direction. So this is positive, so this becomes 11.7 kilonewton meter. Next point is point D. So on the left side of point D there are two forces, so two moments are there. So first one is 11.7 at a distance of 5 meter from D. 11.7 at a distance of 5 meter from point D. Next is, and this tend to rotate the beam in clockwise direction, so it is positive. Next is 10 kilonewton as at a distance of 4 meter. It tend to rotate the beam in anti-clockwise direction about point D. So the net 18.5 kilonewton meter. Now the last point is point B. On the left side of point B there are three forces. First one is RA 11.7. it is at a distance of 6 meter from point B. Next is a 10 kilonewton is at a distance of 5 meter, and 20 kilonewton is at a distance of 1 meter. 11.7 tend to rotate the beam in clockwise direction, so positive 10 and 20 both rotate the beam, tend to rotate the beam in anti-clockwise direction, so both are negative, so net effect becomes 0. Now plot all these points on this reference line. So first is A is having 0 value, C is 11.7, then D is 18.5, last point is B 0. So join all these points with straight line. So this is the bending moment diagram for a simply supported beam which carries 2-point loads. If you have any query related to this tutorial, you can post comment. So thanks for watching this tutorial. Stay home and save lives. Thank you very much.